When you start Atmel Studio, it takes a long time to come up. There's my icon. When I click that, it can take anything up to a minute to come up. However, it does give you this little display here which tells you that it's on its way up, which is a nice touch because not all programs do. However, by the miracle of video editing, look at that, it's up. When it comes up, it usually displays this screen. This is called the start screen. If it doesn't, you can get it by clicking View and Start Page. You see the little symbol there to the left of Start Page. That is repeated up here. So if you click that also, it'll bring up the Start Page. Now we'll start a new project and we will call it Increment R16, because that's about all I'm going to do with it. Click OK, and the first thing it asks you is what chip are you going to compile this for. So we're working with the ATtiny85, so you select that. You will see down here that the AT85 can work with the STK500 programmer, which is the programmer that is emulated by the Arduino Nano. And we've also got a simulator, which is important because not all of the chips here do have. If you take the ATtiny87 for example, you'll see that it doesn't have a simulator. We're working with the AT85, so click OK and it creates the project. Now if you try to compile this, it won't go into the simulator because we haven't got the simulator active yet. Where it says here no tool, you want to click that, and then next to tool choose simulator, and then you can simply close that. If you forget to do that, it will remind you when you try to compile it anyway. To compile it, F11, the function 11 key, is to single step. So you can't single step unless you compile it first. Similarly, if you have a breakpoint set, then function 5 key will go to the breakpoint, which also involves compiling it first. So we'll use F11. It compiles it. This is memory obviously, but we're not going to be looking at that at the moment, so I'm just going to it's put itself in there, that's okay. I'm just going to close it in fact. I want to show you some of the things here. So here we have our main program. Here we have our I/O panel where you can look at, for example, the ports there, or the timers, or the A to D converter, the analog to digital converter is there, and you can look at its registers. Now one of the things that you notice here is that the port is chopped off here. These panels can all be pulled out to the side, and when you do pull it out to the side, you find that these are still chopped off. There's supposed to be 8 bits in there, and we're seeing 7, and that's a bit of a nuisance. When I first came across this, I messed around with it for a long time before I found out how to correct that. And in fact, I set the width of the column, closed the program, and then reopened it again to get these all to show. It's laughably simple. There's you can stretch them here. However, remember that, because it did take me quite a while to discover that. These are the registers down here, and if you didn't have that, then you can choose them up here, registers there. So that'll bring up your register panel. This panel here shows main. Sometimes when you first bring it up, you haven't got main up. This is all just a big blue screen. So if you double click main over here, that brings up your main program. If you're writing a program in which you want to set a bit in port B in order to raise a voltage on a pin on the chip, then you can write out R18 X 1, because you're going to be setting pin 1 high. However, if you don't want to remember that port B is R18, then you can write out port B 0x01, and it will find out that port B is 18 from this file here in the dependencies, TN85 def, and if you double click that, it brings up the dependencies file here. If you search this, Ctrl F for the find box, and you put in there port B, and there it is there, and it tells the compiler that port B is R18. Similarly, if you want to write, instead of the 01, you want to call it PB1, then there again it will look that up in here, and it will find that PB1 is a 1. So it'll be able to set the right port. So if you want to look for your definitions in the definitions file, that's where it is. Dependencies TN85 def. Now then, let's just get rid of all of that again. Here's our little project in which we are going to increment 16, register 16. So I press F11 to compile it, and it goes to the first instruction, and then we can single step it using F11. Down here in the registers file, in the registers display, you see that R16 is 0. If we single step that, it's gone to 1, and because it has just happened, it shows it in red. Single step it again, goes back to the start, and we'll continue to increment that. Before the start, if you have load immediate R17 with a 254, for example, then here you want to compare CP R16 R17, a couple of no-ops, and then rjump back to start. Now we need to come out of here back to programming mode, so Ctrl-Shift F5 will take us back again, and then F11 will recompile it. It can't step through that unless it's been compiled. So we start stepping through that, and R16 is not comparing, so it just keeps going back to start. If it did compare, it would jump from here to label 1, and it would execute these things, but it's not comparing, so it's not jumping out of there. However, if we want to see the point where it is going to, then we want to set a breakpoint here, but not just any breakpoint. We want to set it with a condition. If you put the mouse on the breakpoint, you see this little cogwheel above it. If you choose the cogwheel, click it, and there you can set a condition. Now you can set the R16 equal, it's like the C construct, equals so 253. Now it'll stop when R16 is equal to 253, and that way we'll be able to single step it to see what happens next. So if I press F5 would do it, or otherwise I can click on this green arrow, and there it immediately stops there. If we look at R16 there, we can see it is Foxdog, which is 253. Now we can single step it and see what happens. So it goes back to start, it increments it again. Now it's got to the magical 254, which is the same as R17, compares them, and there it jumps over that goes to label 1, does its couple of no-ops, and it goes back to start. So I just wanted to show you that this breakpoint condition. You can also disable breakpoints. If you go to this thing that looks like a solar eclipse, you see the breakpoint, it goes very feeble looking. It's just got a red ring around it. That means that it's disabled, which means that if you click this, it won't stop at the breakpoint, it just goes over it, and you've got to stop it with this thing. You've got to break it out of that cycle. So, if the breakpoint doesn't have a condition on, it's a full red circle like that, and when you do that, you see it just goes to a red circle, not a filled in circle. I would like to quickly show you the search box. First of all, I'll just close this and I'll open. We'll go again to the start page, and I will open something here that's got a bit of text in it, right flash, and it opens the project. Let me just close this little window because it's kind of in the way. Now if I bring up the search by pressing Ctrl-F for find, and I'll just put in the LDI, load immediate, because I know that there's lots of them, and as you see it highlights all of them. It highlights in grey the one that it's looking at, but it highlights in orange all of them. Now this little box, it looks like a very small box. It looks like a pretty primitive sort of search facility, but in actual fact it's not. It's a full function search. So there we've got the replacement field. So when you click that, it brings up the replacement field, and I can, let's just put a LDI in uppercase there, and we can search for the next LDI here. You can see there the dark grey thing going down the LDIs. If I press this symbol here, it will replace that with the replacement string, and if I keep on pressing that, it'll replace more and more of them. If I click the one to the right of that, that replaces all of them throughout the program. So I think there you can see that they've all gone to uppercase now. At the moment I'm doing a search on LDI, and it's finding all of the LDIs, load immediate. If I click this thing here, that's the case sensitive search. So now it doesn't see any of them because it can't find a lowercase LDI. Okay then, I'll just put in the LDI, and suddenly it finds all of them again, and we will just reconvert them all to lowercase. When you cancel these buttons, if you cancel that, it looks as if it hasn't cancelled. You see it's still highlighted, which is a bit odd. You've got to come out of the box and click outside of the box to make that go away. That's something that puzzled me for a little while as well. This symbol here is the match whole word search. So if you've got LDIR, for example, then it won't find that. If you turn this into LDIR, at the moment, LDI, it's finding all of those, and it finds the LDI in LDIR. If you select the whole word search, there you'll find, I don't know where, oh there it is. It doesn't find that one anymore because LDI is not the whole word. There again, you've got to click outside of the box to make that go away. This little symbol here is a regular expression search. Regular expressions are complex searches that allow you to search for strings in which, for example, there is a date starting at the 9th character, which is 2 numeric characters followed by a slash, followed by 2 numeric characters for the month, followed by a slash, followed by 4 numeric characters for the year, and at the 2nd and 3rd positions there are 2 alpha characters, a string of 2 alpha characters, which must be either AP or ST or NX and nothing else. So you can write searches for stuff like this, and it'll find all these complex strings. It'll it'll do a sort of wildcard search, but regular expressions are pretty complex, and I'm not going to cover it here. In any case, I can't cover it because I don't know it very well. I can do reference and figure one out if I really need to, but it's not very often I need to, and you're not likely to need it in a document like this. If you want to know more about regular expressions, search on YouTube. There are several tutorials on them. Apart from that, this little arrow here is the search, to search for the next string, and the little caret to the right of that, if you drop that down, that will say find next or find previous. If you choose find previous, then this little arrow points to the left, you see, and then it'll keep on finding previous. So the only way you can get out of that is to come down here and say find next. This little arrow down here tells you can search in the current document, all open documents, current project, entire solution. I haven't the foggiest idea what all of that means. I haven't used any of it. This little cross at the top right hand side of the search box works wonders. Okay, I think that's about it. I will put some notes in the description text below to tell you about useful shortcut keys. There are a lot of them. If you look in debug here, there are a lot of shortcut keys here. For example, F11 there is step into, it says. That's the single step. F10 is step over. When you come to a subroutine, if you're using F11, it will step into the subroutine. If you're using F10, it will treat the entire subroutine, the remote call, as one instruction. It'll just step straight over it and carry on with the next instruction after the subroutine. If you get caught in a subroutine accidentally, if you're using F11 and you step into a subroutine and you don't really want to be in the subroutine, you can get out of it again by doing step out, which is Shift F11. If you put the cursor on a line and you press Ctrl-Shift F10, it will send the execution point there without executing any other instructions. It's very similar to setting a breakpoint at that point and then pressing F5 to run to breakpoint. But if you do that, it'll run from the beginning of the program all through everything it's got to do, and then it'll stop when it gets to the breakpoint. That's not what I'm talking about with next execution. If you put the cursor on that line and press Ctrl-Shift F10, it goes directly there, and that can sometimes be quite useful if you are working on, line 100 and the lines above that have a lot of stuff in that take a long time to go through. You might have lots of loops and stuff in there, and you don't really want to run through all of that. You've written a little routine further down and you just want to go straight to that routine and test it. Then you can go directly to it using Ctrl-Shift F10. When you look down this margin here, you see it's all white. There's nothing in there. If I modify a line, so I'll modify that to ADDR, you see there's a little yellow line here appears. That means that this is a line that has been modified, that is different from the source file, from the file on disk. So it's been modified in memory, but it hasn't been saved to disk yet. That little yellow dot appears here in the margin. Let me just move the cursor away from there. In the margin, do you see that little yellow dot there? Well, that is that dot there. If I save this file, save main, now that line that I modified is the same as the file on disk, and it changes that to a green line, which is also still in the margin here. You can also see that the breakpoint there is indicated in the margin as well. It's handy because you can move the cursor around and find these things. The cursor, of course, is the blue line. So if I move the cursor up and down, you can see it moving up and down. And that grey band, of course, is the page. It goes darker when you put the mouse on it, and that's the page. So there you can see the cursor is outside of the page, and if I put it there, the cursor is about halfway down the page, and in fact there it is. Yeah, so it puts those things in the margin. That green line, as I said, is now the same as it is on disk, but it's not the same as it was when we opened the file. So that is a line that has been changed since we opened the file. That is a line that has been changed during this session. It has been saved to disk, but it's still a change. As I said, I'll put a list of shortcut keys down below. That one, for example, Ctrl-Shift F10 is not in here. It's not under debug. So if I put the cursor on a line here, there for example, and I say Ctrl F10, then it executes everything down to that point and it stops on the cursor line. It's pretty much the same as setting a breakpoint there and then pressing F5 to run to breakpoint. It'll do exactly the same thing. However, Ctrl-Shift F10 will put the execution point there, but it won't execute any other statements in the meantime. Ctrl-Shift F10, by the way, is if you use the right click here, and you can find it in here. There it is there. Go to set next statement, Ctrl-Shift F10. So you can find all of these things by either the right click or by looking under debug. But there's a list of them down below in any case. Maybe handy for you. Right, so we just go back to the start page. You sought to open a project. You can open any one of the projects that you've previously worked with by simply clicking it down here. And here we see increment R16 is not a terribly important program to me, so I would like to get rid of that. So I will say remove from list. Play with R16, there's another one, remove from list. It removes them from this list, but it doesn't remove them from disk. So if we come out of there and I bring up an Explorer, this may be different on your disk of course, but on my disk it's under My Documents. There's Atmel Studio 7, and underneath that is a list of all of my projects, so all of my programs. So there we've got increment R16 that we were just looking at. It hasn't removed it from the disk, you see, it only removed it from the list. Now I'd just like to show you something. From the main start page, I'm just going to open this one, 6 LEDs. If we compile this, and we look at the memory, you can bring up memory by using this little symbol here, and it's put it in here. If we look at the flash, now we see that we're seeing 7 bytes across there. This also is something to be aware of. You can stretch that out a bit and then you'll see 8 bytes, and that's what we should be seeing. And sometimes this doesn't, you find that it fills this whole field here with zeros and you can't see the dots, which are the decode of the bytes. If you simply reselect the memory there, then it'll show it properly. Now what I wanted to show you is this. This is the program memory. So this is the actual program in memory, and it takes up, well, there we are, that's the whole program. And you see it starts off with a 3 Fox Charlie 0, and then there's an 1895 and an 1895 and an 1895 and so on. There are 9 of them, and then there's an 18 Charlie 0, Charlie 030. If you look at the beginning of the program, you see there is an rjump main, and then there's return from interrupt, 9 of them. So 1895 is the return from interrupt. The 3 Fox Charlie 0 is the rjump main, which contains the address, of course, of that main label. So I just wanted to show you that these 1895, 1895, etc. These are instructions in memory, and when the chip is executing, that's what it's looking at. The reason that I wanted to show you that was I'm going to come out of here and I'm going to kill this off, and I'm going to open an Explorer. Got the Explorer open, and this is on my disk. So we've got my documents, Atmel Studio, '7, and then under that, I wish Windows 7 wouldn't do this. It's got all of the projects that I've ever worked on, and they're all listed down there. So for example, Play with R16 was one of the ones we were working on. I'm going to delete that here because it's not a project that I really want to hang on to. Where is it? Increment 16. It was already deleted in the package. It was deleted from the list in the package. The one that I want you to look at though is 6 LEDs, because that's the one that we had open a moment ago. Under there we've got two directories, VS and 6 LEDs again. If we open 6 LEDs and we look in there, there's main, which you can look at with an editor, and that's the main program. And if you look in debug, there's 6 LEDs hex, and if you look at that with an editor and you look at it there, you see 3 Fox Charlie 0. Does it ring a bell? 1895, 1895, 1895, and this hex file, 6leds.hex, this is the file that actually goes to the chip. Okay, I just thought that might be of interest to you. Alright then, so that's your directory structure. Right, well, we covered a few things. We covered how to start Studio 7, how to open a new project, setting the panel display, setting the widths and making sure that everything is visible, setting conditional breakpoints. We looked at the definitions file where the predefined words to describe registers and certain values are kept. We looked at setting a conditional breakpoint and how to temporarily disable a breakpoint without losing its place in the program. I have used that to good effect. We looked at the search box. We also saw the green and yellow change indicators which get reflected into the vertical scroll bar. We also looked at the other indicators in there, for example the breakpoint indicator, which also goes in the scroll bar, and of course the cursor. We spoke about the shortcut keys, which you can find by right-clicking in the main display or otherwise by looking in the debug menu. I will also put a list of the useful ones that I use in the description text. We looked at the directory structure and the hex file, which is produced by the compiler, the file that eventually goes to the chip. And we looked at how to delete unwanted projects, firstly from Studio 7 and secondly from your disk. So there we are. I hope that will put you in a better position to understand the rest of the course and to be able to operate Studio 7 as we're going through it next time.